And hello everyone, welcome back to another tutorial. So in this course we are going to be learning about Pascal. Some of you might be coming along from my Delphi course, which is OOP Pascal. If you just want to get into programming, I still recommend that Delphi course above just normal Pascal because it kind of builds up on this concept, but you don't need to know Pascal out of the box to start with Delphi. But if you're just here to learn Pascal, then welcome. So in this tutorial, we'll be talking a little bit about what is Pascal and then running our first Pascal program. So Pascal itself is a general purpose, high-level programming language. It was created in the early 1970s and it produces efficient and reliable programs, as I've just said, and can be compiled on a variety of computer platforms. So if you're on Windows or Linux or Mac, it can compile to those. It's also strongly typed, which means if something is a number, you have to specify it's a number. If something is a piece of text, you have to specify it's a piece of text. And later you can't change what you set it as. This is pretty normal for languages such as Pascal and C++, Nim, and so on. And whilst Pascal is primarily a functional programming language, meaning it does not have OOP, it does now actually support OOP. And that's kind of where Delphi also comes in a little bit, but we will also touch on OOP a little bit in this course. So let's create our first Pascal program. I'm going to create a new file and call it main.pas for Pascal. And here you could also go search for extensions to help with the .pas extension. So here you'll see you get like Pascal language support, you can install that. Here you get Omni Pascal for Delphi, and if PC supports a free Pascal. Depends on what you want, you can go get whatever. I'm just selecting the first one and hoping it works. Now when you create a Pascal program, you need to give that program a name. So we have to go program, and here you could give it a name. So my first program. Then this space here right underneath program is where you can put a bunch of things to tell Pascal what the program is going to use, such as importing modules like math, which you do in Python. You go import OS. Here is the same thing, or in C++ when you have hashtag include IOStream. In our case, we could do something such as uses CRT. This allows us to use read key, which allows us to see the console when it displays an output. This is primarily useful if you're on Windows that has like a pop-up console, which is somewhat annoying to work with. And then finally, we can go here and just say begin and end. And this is a scope. So this scope is where your code will be going into. So this is a very basic Pascal program here. At the bare minimum, you'll need about 3 lines just for this little program. Not that that really matters. As for comments, comments is a piece of text, and also take note of the semicolon here. It's actually important. In this case, there should not be a semicolon. There should be a dot, a period. Not a semicolon, but a period. This is actually very important. It did confuse me at the start. Now back to comments. A comment is a piece of code that will not be read by the computer. So when we go like this, these two curly braces is a block comment, meaning anything inside of these will not be read by the program. If we were to just do this, we'll get an error when we try and run this because this is not valid Pascal code. But this comment can allow me to explain what my code is going to do. You also have forward slashes, which will do 1 line. Then on the next line, it will be normal code. But the more forward slashes you use, the more lines it will take. So these is if you intend to do a bunch of lines after each other. And these is if you want to do maybe 1 or 2 lines, but you don't want to go full block mode. So you just comments, you can use them to kind of explain to yourself what this program does. Now this here is also a block comment. So this is the same as this, which is the same as almost the same as this. These two are block comments, and this is a single line comment. These two, it doesn't matter which one you use. I mostly see people use these comments, but at the end of the day, I don't think it really matters which one you use. It's up to you which you think looks better or is easier to use. Now let's put some text on the screen. We can just go right line, and take note, here we should add single quotes, not double quotes, but single quotes. And then hello world. And then add a semicolon at the end of this line. Semicolons are very important inside of Pascal, and you'll notice a lot of times if you get an error, most likely you just forgot a semicolon. So really remember your semicolons. If you're on Mac, you should probably have free Pascal as well. I don't know. And if you're on Linux, you can just go pacman-s fpc, or I guess you can search for it, and we should find here fpc, free Pascal compiler. This is what we will be using to compile our Pascal. This is our compiler. Now, if you have a compiler installed, then on Windows you could probably just press a run button and it will work. So if you have Delphi, you can just press run and it should work. If you are on Linux or Mac, you can just go fpc for free Pascal compiler, main.pass, and this will compile your code. So here you see it's giving us a bunch of information. It just compiled the code. Here we have an object file. This you can use to kind of link files together and whatnot. It's not too important for our cases. It's more something a little bit more complex. Then we have main. Main is if we go /main, and this will run the program. If you are on Windows, you can just double click on this and it should run it. Then you'll get a little screen that just pops up and goes away. To keep it from going away, you could just put at the end of your program, read key. And this requires the CRT here. Without the CRT, this is not a valid command. Once you do that, it will wait for keyboard input. So we go like, if we compile it and then just run it, then as you can see, it's now waiting for me to press a key. Once I press a key, it will exit the program. So if you have one of those consoles or terminals that just pops up and then goes away without you actually seeing what's happening, read key can help you prevent that. I don't need it because I have my own terminal here. So I can just use this. And take note that Pascal is not case sensitive, meaning this right line could also be right line like that. That's perfectly fine. This begin could be begin, and this end could be end. This is perfectly fine. If I were to compile and run this code, it will compile and run it without an issue. So take note, whether your things are capital case or lowercase, it doesn't matter because in Pascal, they don't really care. And that is the basics of just getting into Pascal, what Pascal is, and writing your first program in Pascal. So first off, I would recommend you get Delphi Community Edition. It is free for the first year. Just create a new email whenever you want to use it again, because it's free for the first year, but then you have to pay for it. Just get a new email every time you want it. A throwaway email. Anyhow, so what you could do is you could say File, New, Console Application, and here it will generate a console application for you. You won't have to worry, your font won't be this overly massive. Mine is just this big because why not? Cool. Then you just want to say File, Save As, and here I'm just going to create a new folder. We can call it 2, because personally to me it doesn't matter. You might have a specific folder you want to save these things in, whatnot. You can name this whatever you want. Just make sure the .dproj extension stays there. This is like the .pass for Pascal. And you can name this whatever you want. I'm just going to keep it project 1, save. If you press Ctrl and D, then it will format your code for you. This is one thing I really love about Delphi. So if we go like this and we say sleep, and let's go 5,000, and I'll explain this in a second. And we do this. When we do this, we press Ctrl D, it will format it for us, and then just Ctrl S to save. If this here is green, it means your code has been saved. So this line here has not been saved. If I press Ctrl and S, or if I go here and say save, it will become green because it has been saved. Cool. Now this sleep here is what you can use instead of read key. So notice in my previous video I left a comment saying if you're on Delphi you have to use sleep instead of read key. Now what sleep does is it just, if we run, then you'll note the terminal doesn't just appear and go away, it stays here for a few seconds, in this case 5 seconds, because this is 5,000 milliseconds, which translates to 5 seconds. But if we were to comment this out and then run it, you'll notice it just pops up and goes away. So what exactly is a data type? Now a data type is basically what type of information you want to store or have. In our case, we can have a ton. We could have integers. Now an integer is a whole number, so -9, 99, 32, 1, 0, -2. All these are considered integers. You also get a real, also known as a double. Now a double is double the size of a real, but we don't need to get too deep into that yet. Now this is like an integer, but it can have floating point value. So -9.21, 3.14159, and 99.0, -99.0. These are all real doubles, floating point values, all of these. Next up, you also have things like Boolean. So Boolean. This is true, which would be yes, or false, which would be no. So true or false, that's Boolean. So it's yes or no, 1 or 0. And then finally, you have string. Now a string is a piece of text. So this is a string. This is a string. Take note, strings use single quotes, not double quotes, single quotes. Anyways, a string is just a piece of text. You also have subsets of this, like a character, and a character would be something along the lines of just one character instead of a whole string. So X or 8 in quotation marks, 1, A, all of these are characters, whilst a string is basically a more than one character. So this is a character and this is a string. Cool. Now let's talk about variables. What exactly is a variable? A variable is like a little box that can store something for you. So let's say you want to move from one place to another. So you want to change houses. You have been living in Toronto for, let's say, 5 years, but now you want to move to Mississippi. Well, then you will need a bunch of boxes that will store things for you. Now you can think of these boxes as variables, and what's inside of them is their values. You can think of it as like that. So let's say I want to store someone's name. Now I can create a box and I can put someone's name in that box, and whenever I need their name, I can just get the box and take their name out. If this is a little bit confusing, don't worry, we'll actually go and show you an example. So to declare variables, you need to use the var keyword before this initial begin here. Now this var keyword will allow us to specify variables such as age, which is of type integer. So this age box will store a number value. So this variable age will store an integer. Similarly, we could do something such as first name, which will store a string. Take note of my naming convention. You cannot use spaces. This will be two different variables. So first name, and we're using camel case. You could also use Pascal case, or you could use camel case, or you could use snake case. However, snake case is somewhat discouraged in Pascal, so I would recommend not using snake case, but camel case or Pascal case. On the end of the day, the casing doesn't matter that much, just so you know what's happening. So here I know this is first and then it's a new word name. If it was just one small word, I will have to go first and then I will have to automatically determine, this is its own new word. And the more words you add, of course, the bigger it gets. First name is very cool or not. So the longer this is, the more difficult it will become to read. But if it's camel case, then first name is cool or not. And now it's automatically way easier to read. Anyhow, so now we have a box that can store a text value. And let's say we want another box that will store a string. So now we could go and say their hobby. And this is also a string. Now you could do this. You could declare them on their own separate lines. However, I actually prefer to do this, using one line to store everything of the same data type. So instead of having like 15 lines with the same data type just underneath each other, we have one line with all 15 in it. And this will assign both of these the data type of string. And then finally, we can create one more letter, and this will just be char. Well, yeah, we'll be of type char. And this can of course hold a single letter or a single number value in quotation marks. Now down here, we can actually, I'm just going to remove this part here. I don't need it. And we can just say sleep 5000. Cool. Now in this part here, we can start assigning values to our variables. For example, age becomes 15. Take note, we use a colon and an equal symbol. This is referred to as becomes. And then we could use this variable. So write line, and here we could specify I am age years old. So right here we have a write line that says I am, and we use a comma here. So after this quotation mark, we use a comma to say we're going to start something new. We put in this age variable, which will display 15, and we say years old, again in quotation marks. If we run this, we get I am 15 years old. Cool. Now we could go here and we could change this to, let's say, 20. Now it will display 20 years old. Now you might be wondering, okay, but what is the use of this? When will this ever be useful? So let's say instead of using this variable, we said 12. And tomorrow I will be 13 years old. But now this is, I am 12 years old, and tomorrow I will be 13 years old. And I could say, write line, my name is Jack. Jack, and let's actually do this like that. Jack is a cool name. But I want to, I'm just going to go to a new line here. Change my name to Nick. I also like watching TV. Alright, so now here we have a few lines where it says, I'm 12 years old and tomorrow I'll be 13 years old. My name is Jack. And let's also specify the age here again. Jack is a cool name, but I want to change my name to Nick. I also like watching TV. If we run this, we'll get what we expect. So I'm 12 years old, wada wada wada. Now, let's say here, we forgot to make this a capital case J. Now, okay, this is just one place, so we can just go like that. Now, imagine this program was 50,000 lines. Not just 3, but 50,000 lines. This was a 50,000 line story. If we run it, we'll get what we expect now, Jack with a capital J. Now, let's say we're done with the story, but we want to make the character a bit more older, so they're a bit more mature. Now we're saying, okay, we want to change the character from 12 years old to 34 years old. And now here we go, 34, and then you run the program, but then you notice, oh wait, I forgot at the other 50,000 places to change this value. So now here, instead of 13, we have to go 35. And let's say here, they're already 35. So this is the next day. So now 35, 35, 34. This is somewhat confusing. And imagine this is just 3 lines. So if this was like 1,000 lines, this would be horrible because now you'd have to go and figure out what you got to change. Now let's say we brought variables in here. So now we have age, which is 20, first name, which becomes Jack, and hobby, which becomes watching TV. There we go. So now here our 3 variables has been given values. Now here we could replace all of these with our variables. So I am 34, we could just use quotes here, say age. And here we're 35, we can say age plus 1. So now age will be plus 1. Then here we have a name, so now we can say first name, and here we could say age plus 1. And here we could again say first name is cool, but I want to change my name to Nick. I also like watching TV, and here we could specify hobby. Now if we run this, we'll get what we expect. So I'm 20 years old, and tomorrow I will be 21. My name is Jack, 21 years old. Yeah, a little fast. Jack is a cool name, but I want to change in my name to Nick. I also like watching TV. Let's say we want to make the character older. Now we can just change one line, and we do like 40. Now the character will be 40. I'm 40 years old. I will be 41. Jack, 41. And imagine this was 100,000 of lines that you had to write here. And just so changing one line, you changed it everywhere. Same with first name. Let's say instead of Jack, you want to go Mike. Run that. I'm 40 years old. Name is Mike. Mike's a cool name, but I want to change it to Nick. That is cool. And as for watching TV, you could change this to anything else. Watching anime. Run this. And now I like watching anime. Now, halfway through the story, our age does get older. And we don't always want to just add plus 1, plus 1, plus 1 everywhere we use age. So we can say age becomes age plus 1. So we're saying age becomes 40 plus 1. So now age is 41. So here we could just say age. We don't need to specify plus 1 anymore. Same with name. Here the name changes to Nick. What we could do is we could still specify first name. But now we could go first name becomes Nick. So now we reassigned, we put a new value inside of this variable here, inside of this box. And now we're using it here. And this is great because now we could run this and there's 41, Mike, Nick. And the nice part is even if we have 10,000 lines of code, we just have to change the instance where we need to. So instead of Nick, we say we want to change it to Jack. One place and all the lines following that place will have the same variable value. So whilst these will work off of these variable values, after this one here, this age will be a different value. And this first name here will be a different value after this. This might be a bit confusing at the beginning, but the idea is that you just kind of understand what a variable is. You might not understand the use case that well yet. Now, Sometimes you want variables, but they should only store values. They should not ever be able to change. If that is the case, you would want a constant variable, something that will always be constant and never change. For example, const. When you declare this, anything after this is a variable that will be a constant. So let's say VAT. VAT is 0.15. You don't have to specify the data type. They will figure it out for you. In this case, they know this is a real or a double. Now we will always know what VAT is. And take note, I'm making this all camel case or all capital case. So I know this here is a constant value. And then here you could do something like VAT value. So to split these, you could use snake case. Anyhow, now this is a constant value. It cannot be changed. And take note, it uses an equal symbol and not a becomes. Now we're just going to remove these. We could say right line VAT is VAT. Like that. If we run it, it's like a normal variable. So VAT is, and it do add a few things here, but you don't have to worry about these extra values. Anyhow, so now VAT has been set, and we cannot go VAT becomes 99.1. We cannot do this. You'll see we get an error here that says left side cannot be assigned to. So VAT cannot be assigned to this because VAT is a constant. It will never change. This is just so you don't have to repeat the same value over and over and over again. But you don't ever want it to change either. And then finally, let's take a look at this character. We can just say letter becomes C. As simple as that. Now we have a letter. We can go right line letter like that. Run it and we'll get C. That's just so you know what a letter is, but you cannot add anything else here. Otherwise we'll get an error that says incompatible types, char and string. And that's the basics of variables and how to use them. So let's first start with something basic. Let's say we want to do this. So now we have a name and, let's go first name. And this first name is a string. Now the issue here is, let's say we don't want to use the string value here. And this is a very basic example, but sometimes your types and stuff, it could become a long list of things that you have to type. So let's say we want to change this string here. So you don't have to say string anymore. We can then say type, and in here say text is equal to string. Now, and take note, this is not becomes, this is equal. And then now we can say text. And this will still work. If I go first name becomes whatever that is, we can still right line first name without an issue. So here we get AJCAS. So it still works. We could even go here and say XXX and do it here. So it doesn't have to be related at all and it will still work. So this is just an example. Generally, you don't want to change something as basic as string. To give you a more impressive value or something that you can do is, let's say you want all the years in the month, or all the months in the year. There you go. So now this value, this type you define can only contain these values. So when we go here and say month, and month is of type months, then now if we were to say month here instead of first name, then here we can't say this. This is not going to be allowed. If we try and run this, we get this error. But we can go something like MAR because that's a valid value here. Now if we run this, we get MAR. So this is a way you can almost define your own types. In some languages, this specific example might be known as an enum. So a value where you can only have specific values in it. But yeah, that's a story for a later date. Now let's take a look at subranges. These are kind of the enumerations I was talking about earlier. So I'm going to get rid of type here. And let's say point. So this is the point someone can score on a test. 1 to 100. So we're saying someone can score points on a test from the values 1 to 100. That means we can go here and say points, and we can say that becomes 100. That will be perfectly fine. If I were to print out points, we'll get 100. But if I were to say, let's say 110 and run it, it will tell us we have one warning, because 110 is not a valid value in points. It won't throw a compilation error because this is just subranges, so it's not that big of a deal if it's a little different. However, we will get a warning. So if we were to say 90 and we were to run it, we won't get a warning anymore, as you can see. You can do the same for something such as, let's say, the alphabet. So let's go alpha. And here we could say this is the values from A all the way to Z. And you later on see that this can be especially useful for checking. If you're coming from a Delphi course, you might remember this, and you might remember this checking can be very useful. And in here we could say this is the letter L. If we were to print this out, we'll get the letter L. And here we could have P, and that will allow us to have the letter P. For once, just change this to say something else. I'm going to call this main program. I think that looks a bit better now. I just wanted to change it since we never touch it. And in here we can declare two variables, an integer and a double. A double is the same as a real. However, I believe a double can contain double the value, so double the length of items after the dot. So let's say if a real can only contain 7.1514, something like this, then a double will be able to contain 7.151493, double this amount. So 4 here, 4 here. And this isn't a real life scale. A real can hold a lot more, but I believe a double is double the amount of a real. Cool. So let's begin with very basic math. Let's say we have right line. Here we can say 1 plus 5. We know this is very basic math. If I were to run this, we'll get 6. We know this works. You can do the same. You can say minus, and this will work. It can go into the negatives, but it will work. So here we can go 10 if we don't want it to go into the negatives. Now it will be 5. So plus and minus, very simple to work with. Now I'm just going to make x. Let's make this 9. Why not? And let's say y becomes x divided by 3. So this right here we can use for division. So if we were to now display y, so we're saying 9 divided by 3. And now we display y, we get 3.0000000. And go 3.3, and that will give us another cool value. Another thing you can look at is if we were to say 9 div 3. This value here, this div, will produce an integer. So this division symbol will always produce a real or a floating point value, or a double. So this divide here, this will produce something like 3.1415, whatnot. This right line here, with this div here will always produce an integer value. So if we were to print this out, we'll get 3. If we were to say 3.3, print it out, we'll actually get an error because this can only work with integers. So if we were to say x div 3, we'll get 3. But it can only work with integers. I cannot say y div 3 because then it will kind of break. So div is what you can use if you want to get an integer and you don't want a double or a real and you need an integer. Then div is the way to go. Similar, we can of course also use times. So let's say we have 10 times 3, which is this asterisk, that means times. Then we get 30. Or we can say -2 times 3 and we'll get -6. So simple times, very easy. And then last, but definitely not least, mod for modulo. Modulo is very special. A lot of people do struggle to grasp the concept at the start, but modulo is actually very powerful. It's very similar to division, but it is not division. Let's say we have 9 modulo 3. This value here, and we can actually prove it by just going here. 9 modulo 3 will give us 0. So instead of 3, this will give us 0. If we were to say div, you'll notice this gives us 3. What modulo does is it gives you the remainder. Some people don't like it when others say modulo gives you the remainder because it's actually a little bit more complex than that. But basically, 9 divided by 3 has no remainders, so it's 0. But let's take an example such as 10 mod 3. Now if you were to do 10 divided by 3, you would get 3.333. You'll get 3.333, I think. Now, if you might remember that when you were in school, you had to rewrite this as 3 res1. You might remember this from school. I used to do this in school, where we had to say 3 res1. That means there's 1 left, because 3, 6, 9, but then 3 cannot be divided into 1 anymore. So it's just 3, 6, 9 with 1 left over. This res1. This is modulo. So now here we can say 10 mod 3 and we'll get 1. So that's the remainder left over after division. Or we can say 10 modulo 4. Now we'll have 2 because 4, 8, and then there's 2 left that cannot be divided into 4 without having to become a value such as this. You might not see the use for something like modulo right now, but I recommend once you learn or know about if statements, you should go search up FizzBuzz. FizzBuzz is a solution that can be solved with modulo. For example, the idea is, let's say every time we're counting down or up to 100, it doesn't matter if you're going up or down. So you want to go up or down to the value 100. So that's you're starting at 0. So 0 to 100. Then let's go 1 just to make it easy. Then for each value that it can be divided by 3, you should say fizz. For each value that can be divided by 5, you should say buzz. And if a value can be divided by 3 and 5, you should say fizz buzz. This solution might seem very simple at first, but once you get into it, you'll have hundreds of lines of code just to do this, where if you use modulo, it can easily be slimmer down to maybe 10 lines of code, if not less. These allows your program to make decisions. Isn't that absolutely awesome? So you can use if statements to figure out what your program should be doing. So should your program execute one part of the code or a different part of the code? It's awesome because now your program can start thinking for itself. Take that with a tablespoon of salt. Anyhow, now an if statement is very simple. If true condition, then begin and execute code. This is an if statement. So we can say if true, then you can write line. And remember, true and false is like yes and no. So true would be yes. So if yes, and here you can say execute code. And you can put as much code in here as you want. You're not limited to just one line. This begin and end is very similar to this begin and end. All right. And take note, this end here has a semicolon, not a dot. Now here, let's execute it. then oh, we actually get an issue. Oh, it could be because I have that var there. Let's just remove it. There we go. So execute code, and execute code. If we were to say false, which is no, then we get nothing, just one warning issued, because this will always be false, of course. So this is a very simple piece of code, but it's very powerful. So now you can decide if something should execute or not. So let's do a few conditions here. There's also another way you can do if statements, and that's in one line. So if true, then write line, I am powerful. There we go. So I am powerful. This is a one-liner if statement, meaning after this line, this if statement will no longer just run. So to give you an example, here I will say write line, and here we can say 2, and before we can say write line 1. So this is a one-liner if statement, meaning it does not go to the next line. If you wanted to go to the next line, you have to use begin and end. But here it's only one line. So if we run this, we'll get 1, I am powerful 2. But if we say false here, it will give 1, 2. And of course, if we were to say begin or true, and then begin and end, we're going to of course split this onto the next line. Then this will of course be a block quote, meaning we can have a bunch of these, but once it reaches the end, it will no longer execute. So 1, I am powerful, I'm powerful, I'm powerful. 2, if I say false, then now we'll get 1, 2. So this block code was entirely skipped. So without a begin and end, you can make it a one-liner, meaning only one line will be executed. I'm going to use this just because it uses less code and it's a little bit neater. So if we say true, it should still execute. There we go. Now, true and false on their own isn't very powerful. However, you can create values that can simulate true and false. For example, is 5 larger than the value 2? And you might remember this from school. This one will always try to eat the larger part because that's a mouth. Remember, so is 5 larger than 2? 5 is larger than 2, so this will actually give us a true value. So this will be true. But if we were to make it like this, oh, no, like this, then it will be, is 5 smaller than 2? And that will be a false value because you're basically asking, hey, is 5 bigger, or in this case, is 5 smaller than 2? No, 5 is not smaller than 2. No, which is false. So this will not execute. But 5 is definitely bigger than 2, so this is true. Now, I'm going to jump back to a block quote again. So here we go like this, and then end. So this should still work, yes. Now let's say you do this. So now it won't execute. But let's say you still want it to execute something else if it does, if this is false, but you only want it to execute if this value is false. Well, then we can use else. And here we can just put it in there. Take note, no semicolon at the end here. And you can say else begin, and this end has a semicolon. Just take note of that. That confused me at first. And I can say write line value was false. Now if we run this, we'll get value was false. But if we were to change this so this value becomes true, we'll get I am powerful. So this will execute this or this. It will not execute both. So if this value is true, it will execute this and skip this. If this value is false, it will skip this and execute this. And again, you can also do this in one line. So we can say this, if 5 is bigger than 2, then write something, else this. And again, this is a one-line thing. I'm just splitting up into multiple lines. And here, there's not allowed to be a semicolon at the end. So we should just remove that. So yeah, then another way you can do it in one line. Generally, I just say use a block, because if you do a one-line thing, I saw a lot of people in my high school class when we did Delphi, which uses Pascal. A lot of them tried to do this one-line thing, and a lot of times that's what got their marks down, because they didn't want to do the effort of saying begin and end, and then they spent 10 minutes trying to figure out why this if statement doesn't work, but it's just because they try to do two things instead of just one thing. So I would actually always recommend using begin and end instead of this one-liner method, which you're only allowed to execute one thing at a time. So instead of this. Cool. So I'm going to bring my begin and end back. Now you can also do multiple different checks. For example, is the name Jack the same as the name Nick? We're using an equal symbol here, not a becomes, but a single equal symbol. Run this, the value was false. Is Jack equal to Jack? I am powerful, so the value was true. You can also do this with variables. So if I say variable uname, and this is a string, then I can say uname becomes Jack, and then we can test this uname against this value. You can also have multiple, so if we say uname2, and we go like uname2, then you can actually test uname against uname2, so you can test variables against each other as well. I'm powerful, but if we change this to Jack2, they'll no longer be the same. Take note, case actually also matters here. So if I say Jack with a lowercase j and then Jack with an uppercase j, we'll get a false value because casing does matter in if statements and in strings, because a string with a different casing than this is actually a problem. They're not the same because these have different ASCII values, and we're not going to get too deep into that. Cool. Now I'm not going to go through all of them, but just to give you a few more. So let's say we have 5 is equal to 7. This is going to be false. You also have 5 is bigger or equal to 7. This will be false, but this will check if it's at least equal to 7. So if I go like this and I say, is 7 bigger than 7? No, 7 is not bigger than 7. Is 7 bigger or equal to 7? Yes, it is, because 7 is 7, but if it's also bigger, it will be true. So if I say is 9 bigger or equal to 7, it will be true. And of course, you can flip this so it's less than or equal or just less than. And in this, I believe it's not. So is 9 not 7? Yes, 9 is not 7. Is 7 7? Yes, 7 is 7. Yes, 7 is 7. So it will throw this because if 7 is not 7, then do this. Otherwise, if 7 is 7, do this. A little bit confusing, but you'll get the hang of it. I usually just, instead of doing this, I like to go equal and then say, if not 9 equals 7. This makes it much easier because it's easier to read than having to do this. Now it will work the same way because if 9 is not equal to 7, then execute this. But I believe you might want to do this in brackets, otherwise it will say if not 9. Yes. So if you're using not, you will have to use brackets here. Brackets just allow you to split your code up into certain parts. So here, if 9 is not equal to 7, then do that. If 7 is not equal to 7, okay. So you're kind of getting the idea. I recommend you play around with this concept because it's very powerful and very useful. I'm not going to go through all of them extensively because I don't think it's necessary. Let's create 2 new variables. Let's say age, which is an integer, and then open, which is a boolean. Then here we can say age becomes 19 and open becomes true. Now we can create an if statement where we check, is our bar, so let's say we're in a bar, is our bar open? And we should just remove that not. And is the user that's trying to go into the bar older or the same age as 18? If they are, we say you may enter. Otherwise, we can say the same thing, but instead of you may enter, we can just say you may not enter. In this case, they may enter. So you may enter. But if the bar is not open, they will not be able to enter. So this and this should both result into true. You can also use or, which means either one of these has to be a true value. So if we do this, you may enter, because this is true, but this is false. But we say and, we say both this value and this value should return true, otherwise it will be false. So the bar should both be open, and the person who wants to go into the bar should be at least 18. Meaning if our person here is, let's make this true now, and our person is 17, which is just under the age, they may not enter. But as soon as they reach 18, which is the legal drinking age here, then you may enter. Now you can actually make it even more powerful. Let's say you want it to say something when it's not open. But you don't want it to say that same thing if your age is just underwhelming. Then here, right before this else statement, we can actually say else if not open, then. And it's like speaking English. So else if it's not open, simple as that. We then have our begin and our end. And here we can now say right line bar is closed, opens at 8 p.m. There we go. Now we do this, you may enter. But if I say if open is false, then bar is closed, open at 8 p.m. But if I say it is open, but they are not allowed to enter because they're underaged, you may not enter. You also don't need an else statement. You could just as well have done this, and this will work perfectly fine. But then if one of these two cases are not true, it will just not say anything, because else will execute if both of these did not execute because they're false. Then else will execute. Cool. Now there's another more powerful thing we can do, is let's say, let me just go end else. Let's say here we only check their age. If their age is more or equal to 18, then we execute this. But now we can also do you are of age. And inside of this if statement, we can create another if statement. If open, then begin, end. And now here we can say right line you may enter. And here we can say else begin, and you say right line bar is closed. Here we go. They're very simple. But now we have an if statement within another if statement. So now we get a compilation error because here we have a begin, but we don't have an end. So now you may not enter because they're not of age. But if I were to say 19, you are of age, you may enter. But if I were to say open is false, then bar is closed. So it's going to say, hey, they are of age. And then you're going to check here. No, it's not open. So it's going to go to else and say bar is closed. And you can see here, you are of age, bar is closed. So this is called a nested if statement. You can have as many nested if statements as you want. I'm going to create two variables, num, which is an integer, and letter, which is a character. Now a character is basically a string, but it's only allowed to be one character. So where a string is allowed to be something like this, a character is only allowed to be that. So one character. Cool. Now let's say num becomes 10. And let's say letter becomes Z. Now a case statement, as I said, is very similar to an if statement. So we can say case num, so we're checking the number here. But instead of putting our conditions here, we say of. And of course we need an end here. Now we're saying if the number is the value 10, then, and here we can either put a begin and end to put a block quote here. So begin right line I am epic. And we actually write another line. I am very epic. And we can say end. This is perfectly valid. Take note of the semicolons. But you could also do something such as, let's say we say 20. Then here we can just say right line. Num is 20. As simple as that. So you don't need to do a block quote or a block statement, but you can if you want to, depending on what you want to do. If you just want to do one thing, then one thing is all you need. If you want to do a few extra things, then a block scope is what you need. You also check for multiples. So let's say 100, 45, 201. These values you all want to check. Go right line, num is 45, 100, or 201. And then also you can check in a range. For example, 1000 to 2000. Right line, num is very big. This is a case statement. So it's very, very similar to an if statement. However, some do prefer it over an if statement. But now if we do this, we say I'm epic, I'm very epic, because num is 10. If we say num is 1004, it will say num is very big because it's between 1000 and 2000. If we say num is 201, we'll get num is 45, 100, or 201. What if we were to say if num is 32? It will not execute. So it will not choose any of these because num does not fit in there. However, we can say else. So if it doesn't match any of these we've given it, we can just say begin, end, and then right line, number is not one of the allowed cases. Okay, now if we try and run it, we get number is not one of the allowed cases. But if we make it something such as 10 again, we get I'm epic, very epic. And you can do the same thing for stuff such as letters. So now we can go letter here. And now we could do something such as if letter is between A and capital letter Z, then right line, capital letter. Or if A is lowercase a, or letter is lowercase a to lowercase z, we can then start begin and end statement and say right line, a letter is lowercase. And here we could do another case statement inside of this case statement. So case num of 1 to 10, for example. Right line, and num is between 1 and 10. Hooray! And of course we can just end here. And here you can say invalid letter. Let's see, does this run? Letter is a lowercase and num is between 1 and 10. Cool. If we were to make this letter here a capital case E, it will give us capital letter. If we were to make this a semicolon, we'll get invalid letter. If we were to make this a lowercase s, but change number to be 12, we'll just get letter is lowercase. So it's very similar to an if statement. You can see this just of how it's structured, but it's also just as powerful as an if statement. Now, a loop is when you need to, let's say, execute a few commands for a certain amount of times. So let's say you're writing a script that will select each and every menu on, or each and every item on the menu when you go order pizza. Now, since it needs to do the same thing basically multiple times, it will use a loop to loop over the amount of times it needs to do it. So pepperoni pizza, scroll down. Pineapple pizza, scroll down. Chili pizza, scroll down, and so on and so forth. So it will constantly repeat the same things, and that is a for loop, or that's a loop in general. Now let's create a variable I, which is an integer, and let's create our first for loop. So for I becomes 1 to the value 10, so it will count up. Then do the following. We're going to use a begin and end, and we can say right line I. Now, if we were to run it, and we were to resize this, you'll see we get the values 1 up until 10. So I became 1, and then for each value up until 10, it printed that value. So this means we can do something like right line hello world. Now let's say we want to print hello world out 50 times to the console. 1 to 50. Now if we were to run this, we'll get a bunch of hello worlds 50 times. You can also count downwards. So let's say you want to start from 30 and you want to count downwards, so down to the value 20. Well, then you can. So now we can display I here. We run it. It counts from 30 down to 20. Might even just want to put it here on the side. That might even be better. Now, loops have some pretty neat features. Now, let's say if we reach the value 25, we want to skip the loop. Well, we can. So if we go here, we can say if I is 25, then continue. That means anything past this continue when I is 25 will be skipped and it will go to the next loop. So if we were to run this, you'll see we get 30, 29, 28, 27, 26, 25. And I actually have to save the program, otherwise it won't do the changes. Now I'll see 28, 27, 26, 24. So it skipped this right line once it reached continue. We can even go right line, run, just to show you that it only affects everything after continue. So if we run it now, run will still happen, see here, twice, but 25 will not happen because anything after this continue is skipped and it goes to the next iteration. This is a good place to maybe use mod. So if I mod 2 is equal to 0. Now take a look at this cool thing. Now if we run this, we'll get each value that is not an even number. If you want to get only the even values, then we can do that. So if I mod 2 is not equal to 0, then you'll only get the even values and the rest will be skipped. This is also a nice place just to show you how mod works, because I have explained it a little bit, but I haven't really gone into depth with it. And then finally, break. Break is very similar to continue, as it doesn't continue anything afterwards. So anything after break will not execute. The difference is if break is hit, then the entire for loop will stop. For example, I can go right line, begin, and then just right line, end here. If I run this, and let's change break to continue again. If I run this, then we'll get begin and it runs all the way till the end, and then we get end. However, if we were to say break instead of continue, then we'll get this, begin, 30, end. So let's do something a little less complex. Let's say if I is equal to 25, break. Run that. Once we get to 25, then it breaks out of this for loop and it doesn't execute the rest of it. Where continue, we just skip an iteration. Break will quit out of this for loop, but it will still continue with the code after this loop. So break stops the loop and continue just skips an iteration of the loop. When we did the math tutorial, I said that modulo is very useful in something like the FizzBuzz program. Now let's actually do this FizzBuzz program now that we have the skills for it, because this will teach you a little bit about for loops as well as how to use modulo. So let's say we have a program that counts from 1 to 100. Now this program, whenever we reach 3, we should say, it should print out fizz. Whenever we say, or whenever it's at 5, it should print out buzz. And whenever it's at any iteration, so this is like any iteration of 3. So this would be 3, 6, 9, 12. So any iteration of 3, including 15, we can go there. And this is any iteration of 5. So 5, 10, 15, and so on. 20, whatever. But when it hits an iteration that's both 3 and 5, we should say FizzBuzz. So this would be something like 15 is both 3 and 5. That will produce FizzBuzz. Same with 30. 30 is also between 3 and 5, so 30 will also give FizzBuzz. Now let's write a program for that. So first of all, we want to loop for I becomes 1 to 100, begin and end. So we have our for loop. Now, let's say we want to get each of the values that is divisible by 3, right? Now you could go and you could try and write ln, go something like I divided by 3. This is like a valid command. And if you run it, you'll get this, but as you can see, it's not very useful. It's incredibly confusing what's actually going on. And if we were to just maybe print out I before it, then you can get an idea of what we're actually looking at. So now, bloop, we go like this. As you can see, there are ways to figure it out, like which one is a number in 3 and which one is not, but it's somewhat difficult to get that. So what we could do is we could say, if I modulo 3 is equal to 0, then begin and end, and right line fizz. So now if we were to just also right line I, and we were to run this, and I'll explain this in a second, and that's not for equals, that's JavaScript only, and it's 1 equal in Pascal. And I forgot my semicolons as well. Okay, now it should work. There we go. So now it prints out 3, we get fizz, 6, we get fizz, 9. So each iteration of 3, it prints out. The reason for this is, as I said, modulus would go like this. So if we have, let's say, 3 divided by 3, right? Now the leftover of that is 0, because once you divide by 3, there's no like dot left. But let's say we have 2 divided by 3. Now that will give you 0. I believe it's like this. And in this case, we can tell that this has a res. So as we go like from school, this would be 0 res2. And this would be 0 res0. And if we were to go 1 divided by 3, this would be 0.3333, and that will translate to 0 res1. And let's say we were to do 7 divided by 3, and as well as 9 divided by 3. Then 7 divided by 3 will become, and I'm just going to skip the middleman, and we can just go straight to res. That will be 2 res1, because 3, 6, and then there's a 7, but it can't go to 9. So there's 1 left that cannot be divided into 3. And here it would be 3 res 0. And remember, modulus gives you this res, this res. So that is like what's left over. So now each time we hit this, we hit where I can modulo 3 is equal to 0, meaning I can be divided into 3. Then we get this. If we were to, let's say, print out I mod 3, and we were to just ignore this one here, well, we'll see we get this 0, 1, 2, 0, 1, 2, 0, 1, 2, because these are the leftover, so nothing left over, res 0. Then here, 1 leftover, res 1. 2 leftover, res 2. But this can never be more than 2. Why? Because once it hits 3, it hits back to 0, because that means there's no res left. Like with 9, 0, 1, or it's 1, 2, and in 3. 3 divided by 3 will give you a res of 0, meaning it starts at 0 again. Then 1, because then it's 4, 5, which both is 1 and then 2, and then 6 would be 0 again, because 6 can be divided into 3. Anyhow, so that is the basics of modulus. Now let's continue. So now we have this. So each time we have a fizz, it will print out. We can copy this, and we can do the same with 5. So if I mod 5, then we want to say buzz. Now if we run this, we get fizz buzz, fizz buzz, fizz buzz, fizz buzz. But currently, we should also print out, let's say we also print out just the numbers that should be displayed here. So here, let's just go and create a variable called which is a Boolean. Now called by default is false, so called becomes false. Now if either one of these are called, then called becomes true. Then after this we can say if called, then write, and we can just write \n. Then here we can just say write, and now if we take a look at this, or maybe we should just say write line here. Maybe \n isn't quite what we expect. Then here we're already getting fizz buzz where two of them will be together. So we go to the top here, we get, so this would be the first one, so that'd be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so both of them fizz and buzz. So if called, we can just say write line. Else, we can say write line and then I. We run this now, and of course we should set called to false at the beginning of each loop, otherwise it will always be true once it's set to true. Now we run this, look at this, so this is fizz buzz, 1, 2, fizz, because this is divisible by 3. 4, buzz, because this is divisible by 5, so 5. 6, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, and buzz, because 15 is divisible by both 5 and 3. So this is where modulus can become really handy. In this example like fizz buzz. There are multiple ways to do fizz buzz, but I find using modulus the easiest way. And now you also did a little bit with for loops, and you can also go down to, if you wanted to. So 100 down to 1. Now run it, plop. Then as you can see, it works exactly as it should, even if it goes backwards. Let's start basic. Let's create an integer called x. Now, in the previous video, I explained a for loop is a loop that goes from one point to another point. So from 1 to 100, or from 100 back to 1, as an example. Now, a while loop is very similar to a for loop. The only difference is it will execute while something is true. So let's say while true, do begin and end. And here you can write line hello. Now this will cause what is called an infinite loop, a loop that never ever ends. So if I were to run this, then it will just keep printing out hello until I forcefully quit the program. By pressing Ctrl and C, if you're on Windows, it might be a little bit different. Might have to press something else. But on Linux, you press Ctrl and C and it exits. So this will run forever and forever and forever until true is no longer true. In this case, true will always be true. If it's false, it will not execute, like an if statement. So if while false, then nothing happens. Now if we put this back to true and we set x equal to 1, then here we could go x plus equal 1, and then we can write line x, and if x is, let's say, 5, then we continue. And here we could say if x is equal to 10, then break. So both break and continue still works inside of Pascal. If we run this, you'll see we get all the way from 2 up until 10, excluding 5. So the idea here is that this is very similar to a for loop, where you have your value. So for, let's actually create a for loop. So for I becomes, in this case, 2 up until 10. But if we just did like 0 and we started, but anyways, the point still stands. Do begin and end. Then here, if we can say, we can actually put the same value here, like that. And you can put the same thing here, like that. And it will work exactly the same. So this here is the same as this here. However, the only difference is that this while loop works depending on if this value is a true value. If this is a false value, it will break. Meaning you could also go while x is less than 11. It will give you the same output. So if we were to run this, you get the same output. Actually, we should just remove that break so I can prove it. Actually, yeah, we can actually just go 10. Anyhow, so while x is less than 10, so if x becomes more than 10, then it will not loop again. So this basically just checks if this condition is true. If it is, then run this code. Now let's say our x value is 11. If we run this, our while loop will not run. But let's say you want your loop to run at least one time. No matter what this value is, you need it to run at least once. Well, in that case, you have a repeat loop. So repeat until this value is true. So it's a little bit on the other end here. So while this is true, execute this. And this is execute this until this becomes a true value. So let's say until x is more than 15. X plus equal 1. Right line x. Now if we were to go like this, we'll get 12 until x is more than 15. So this will execute while this is false. But let's say it is the same value. So we go like this. So if x is less than 10. Now if we run it, and here we should just flip this around. So until x is more than 10. Otherwise we're going to get like an integer overflow. Anyhow, if we run it, we get 12. So this will run at least once, whilst this will run only if this value is true. So whether this value is true or false, it will still run it at least once. And also the other difference is, this is while this value is true, execute the code, and here it is execute the code until this value becomes true. That's very important distinction to make. And these are the 3 loops you can get inside of Pascal. So you get your for loop, which you can use to for through numbers or letters and so on. You get your while loop, which will loop until the value becomes false. And you have your repeat loop, which will execute at least once. It will always execute at least one time until this value is false, or until this value becomes true. So let's say we have a bunch of friends. So friends. Now we have a bunch of them. So we need to store that we have a bunch of friends. So I have Mark, I have Jack, I have Michael, whoever. Now you could do like friend Mark, and then that can be a string. And you also have friend Mike, and friend Jack. You can do this, but the more friends you have, the more effort it becomes to manage this. And this can be true for so many scenarios inside of programming, where you have so much data that you can't create a variable for each and every one. It's just going to be too much effort. Well, in that case, you can create an array. So an array that keeps all of your friends. So array 1.free, I'll explain this in a second, of string. Now an array is a little container. It's basically like a variable that keeps multiple values, because now we have a variable that can keep one value. But if you have an array, you have a variable that can keep multiple values. So 3 strings instead of just 1 string. So now if we were to do something such as, and I'll explain all of this in a second, friends 1 becomes Nick. Copy this a few times. Friend 2, friend 3. This can be Jack, and this can be Mike. And now if we were to right line friends at index 1, 2, and 3, not 13 but 3, if we run this, we get Nick, Jack, and Mike. So what exactly happened? Well, first of all, we specified we wanted to store an array with 3 items in it, with its indexes starting at 1, going to 3. And this can be more powerful, but that will be for a later tutorial. And it should keep a string data type in it. Then here we can access those indexes. So instead of giving them all a word to align them, for example, instead of saying Nick like this, we just say you have a number. This could be like their ID. Your ID is 1. Jack, your ID is 2. Mike, your ID is 3. And we assign these values like this inside the array. So then whenever we call array at ID 1, we'll get Nick. This is called an index, but I'm just saying ID. So you can kind of think of it as like a dystopian future where nobody has names. They just have IDs linked to what could be their name. Something like that. Anyhow. And in here, friend with the ID of 2, his name is Jack. So in a sense, it's like this. Nick, Jack, and Mike. And our indexes can go something like this. So this guy here, he's at index 1. This guy here, he's at index 2. And this guy here, he's at index 3. So whenever we want to modify each of these, let's say we want to change from Mike to Nick. Cool. Right? Now, it will no longer be Mike, but Nickel. Because here, we said, okay, the value of ID 3 becomes this value. So we can overwrite things. So now, if we were to maybe do this, and then just paste that there. Now if we were to run this, we'll see we get nickel at the end, because we can change it. So basically this value here corresponds to this name here now. Now generally, if you have an array, there's a chance you're going to have hundreds of values and not just 3. In that case, printing out one by one kind of brings in another problem, because what's the point if you're anyways going to have to set all of them manually and then call all of them manually? What's the point? Why don't we just use normal variables then? Well, there's one thing that can be very useful here. So for, that allows us to go through numbers. So if we say for 1 to the length of the friends array, then here we can access each and every element inside of this array. So now let's say right line friends at index I, because I is a number, and this will get the length of this array, which in this case is 3. So for 1 to 3, right line, and display the people in it. So now if this is even 100 people, you'll easily be able to print them all out without having to worry about it. And my bad, I should just declare I, it's an integer. There we go. Run it, we get Nick, Jack, and Mike without needing to do them manually, to print them out manually. And you can use this same method to assign values to them, because this doesn't just need to be used for displaying. You can also assign with it. So if you, let's say, have the data of 100,000 users in your database, you get all of their usernames. So now you have 100,000 usernames. Then this is a way you can go for each and every username and do your thing. Now it should be taken note of that you cannot display an array. So right line. You cannot display friends like that. This is not allowed. So if we run this, you'll see we get an error because you can't read or write variables of this type, because this array is of a special type which you can't just display. So you need to specify what in that array you want to display, as you can see. So you can't display the array itself. Now arrays can become more powerful. In fact, they can have multiple dimensions. Now I'm not going to dive too deep into multiple dimensional arrays, but I am going to show you that they exist. So let's create our variable here, j, and here with friends, let's say it is from 1 to 3 and 1 to 5. And we can say of Boolean. And let's maybe go 1 to 3, 1 to 3. Now, here we have an array that has multiple dimensions to it. So let's actually just turn this back into numbers of integers. Okay, that's going to be easier to explain. Now here we can go for I becomes 1, 2, 3, do. For j becomes, and you can use begin and ends here to make this easier to read. I'm just not doing that because I didn't see the need for it. To 5. So we're saying for I becomes 1 to this 3. And for j becomes 1 to this 5. And they're inside of each other. So we can actually go begin and end. Let's do a begin and end just to make things easier to read. So this, like this, do, and then we can go begin and end. And now let's assign each of these values a value. So friends at index I, at index j, and I'll explain this in a second, becomes I times j. And let's create another for loop, which we can use for demonstration purposes. And here we can write the line with friends. If we run this, we get 1, 2, 3, 4, 5, 6, 7, 8, or not 7, wait, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 9, 12, 15. All right. Now the idea here is this array looks something like this. So the previous array we had, the friends array, would look something like this. 1, 2, 3, right? This new array, this multi-dimensional array, looks like this. So it has 3 arrays inside of it, like this. So that's this 1, 2, 3 here. That means it has 3 more arrays inside of it. And this here gives the size of these arrays. So 1, 2, 3, 4, 5. This is how this dimensional array looks. So it's an array with 3 arrays inside of it, and each one of those arrays has 5 values inside of them. So when we do this for loop, we're saying, okay, so for index 1, that will be this one. So this will be index 1 and then j1 to 5, right? This is index 2 and then 1 to 5. And this will be 3, 1, 2, 5. Now we can split this up to make it a little bit more simpler. Okay, like this. So now let's just move this up here and take a look at this top one. So this is the index 1, 1 to 5. This would be index 1, 1. Index 1, 2. So this one here corresponds to this value here. This one here corresponds to this value here. And then if we take a look here, I becomes this first item here, and then j becomes the second item. And that's how you can assign to specific values inside of each of these arrays. Now, multi-dimensional arrays are somewhat difficult to explain. I do have a Delphi tutorial where I do cover them more in depth. So if you do want to learn more about multi-dimensional arrays, I actually recommend you go watch that tutorial instead. Because in this tutorial, I'm not going to cover everything so deeply. I mainly just want to show you that these things exist. So yeah, that is arrays as well as multi-dimensional arrays. If you're having trouble understanding multi-dimensional arrays, then it's perfectly fine. You don't need to be great in it, because once you need to use them, you'll learn by using them. And with arrays, they're fairly simple. They just a variable that can keep multiple data types or multiple values, compared to a normal variable that can only store one value. So a procedure is basically a piece of code that you can call over and over again that contains some other code that it executes. As an example, this right here is the main procedure of the program. It has some code inside of it, so here, that we can use to make the program run. So let's create a procedure, say hello. And this say hello, and let's actually say Q for say quick hello. And this procedure then has a begin and an end. And in here, you can put any code you want this procedure to run once you run this procedure. And here you can just say write line, hello world, and hello to you too. There we go. So this say hello procedure will run this when we call it. So I'm just going to go here, and we can call this say hello procedure inside of our main procedure. If we run this program, and that's without that bar, if we run this program, we get hello world and hello to you too. And we can of course use this as many times as we want, and we'll print out these values as many times as we call it. So by calling it here, remember the brackets as well, but by calling it here, it will execute everything that is inside of it. It can of course become way more complex, so let's create another procedure called say hello. And this is just going to be a normal hello, not a quick hello. As you can see the difference, one has a Q, one doesn't. And then we can pass in variables that we want to use inside of this procedure, such as the username, their favorite color, and both of these will be of type string, and in age, which is of type integer. So here we have two values that are of type string, so we only need to specify it once here, and here we have one value that is of type integer. We can then create our begin and end, and let's just go right line hello with the username, you are, age, years old, and your fave color is fave color. So now we can use say hello here. So say hello, we can pass in the username, so let's say Jack. They are 21, which is actually later, and their favorite color is blue, and they are 21. Now if you run this, we get hello Jack, you are 21 years old and your fave color is blue. And we can of course do this for multiple people. So here we have Mike and here we have Sally. Mike's favorite color is red and Sally is green. Mike is 19 and Sally is 40. We run it, and now for each one of them, they will have their own sentence constructed, and we didn't have to copy and paste this right line over and over again to get this result. Procedures can as well have their own variables inside of them. You don't need to just pass in values or variables. For example, procedure print sum, and print sum contains num1, num2, and both of them are integer. We then have a var section where we can specify variables that can only be used inside of this procedure. We cannot use these variables outside of this procedure. Take note of that. Then we have ons, which is of type integer, and we have our begin and end. Then ons becomes num1 plus num2, and we right line ons. Now we can say print sum of 10 and 20, and let's also bring a variable in here, my num, which is of integer. We can also go print sum my num, and let's say 5, and let's just make my num something such as 90. So you can also pass in normal variables in here. You don't need to specify set values. Anyhow, so now it has its own variable. We cannot use ons here, so we can't say right line ons. This ons is only available inside of this procedure, meaning we cannot use this variable inside of our main procedure. Now if we run this, and my bad, I forgot my semicolon. Now we have 30, so 10 and 20, and 95, my num, and 5. My num is 90. And this is the basics of a procedure. It executes an amount of code for you, and then you only have to call it once. So if you need to execute a specific code more than once, and the code is very similar, just use a procedure, because then you don't have to copy and paste 10, 20 lines of code. You can just run one line of code and that will do it for you. For those of you coming from different languages, procedures do not have return statements. Return statements are for functions, which we'll get to in the next video. Functions and procedures are basically identical, with the primary difference being functions can return a value back, where procedures can just run slices of code. As an example, let's remove these procedures and rename this procedure to just sum. Now this sum will take in two integers, but we also want it to return an integer. And now it's no longer a procedure, but a function. In Pascal, there is a distinct difference between these two things. So it's good that you know the difference between a procedure and a function. A function is going to expect to return something, whilst a procedure is going to expect to just execute code. Now, to return something, you can just, and we can actually remove this variable here for now, say sum, so the name of the function here, becomes num1 plus num2. Now this will return a value. So here we can now say my num is sum 10 and 90. And now we can write line 10 and, or sum, or my num actually. There we go. If we were to run this, we'll get 100. So it's the same as a procedure. You can still do a bunch of things here. For example, write line, and we can write line 10 here, or even hello. You can still do that. There's no problem here. You can still do things at the end, so goodbye. And you'll still get hello and goodbye, but you'll notice hello and goodbye both execute before this value is printed. Now that is because this value is just returned. This doesn't print out anything or whatnot. This doesn't break or quit out of this function. This value is just stored inside of my num. So when we run this, it stores this value inside of my num. But sum itself, it doesn't get printed out or anything like that until write line. So if we were to comment out write line, we'll only get hello and goodbye. So the reason you're seeing 100 at the end is because of this write line, not because of this. Now let's go into something a bit more complex. How about a function such as isBig to check if this is a big value? And we can just pass in num and return a boolean. So it doesn't need to return an integer. And we can say isBig becomes false to give big a default value. Then we can say if num is more than 1,000, then begin, end, and isBig becomes true. So big will always return false unless num is more than 1,000. Now I know some of you smart guys out there will go, okay, but you could just do this fast. But this is just an example to show you that you can later change this value through your code. So you should be careful, because changing this value could determine the outcome of what is in here. So you should just be careful when you change it, and always to check your if statements. Now, of course, if we were to check isBig and we were to check it with 100, we'll get false. And my bad, this is an integer, so make it a boolean. We can actually even just put isBig inside of that right line. We don't need a number. If we run it now, we'll get false. But if we make this 10,000, we'll get true. And finally, one last example. Let's create res. This is just like a result. Here we can say make, which will be a boolean, and it will return an integer. Now, you don't necessarily need to return a variable with the word res in it as the return value. As an example, let's just make this num again, and let's actually just turn everything back and make this num. If we do this and we run it, we'll get an error. And let's go res, go like that. We'll get an error because identifier is not found, isBig, and that is because this isBig doesn't exist. So this needs to be the same name as your function here. It has to be. but it doesn't have to be. As an example, let's go res here. We can say make, which is Boolean and returns an integer. You could specify a variable result, which is of type integer, the same type that is being returned here. This is generally seen as the better way to do it, because using the function name is just a little bit frowned upon, but using result is generally seen as the better way to go about it. We can then give result a default value of 50, meaning when we call res, we'll still get the same result. So here we could put result becomes default to 50. And then at the very end of the function, we say res becomes result. Now this is an optional way to do it, but generally when I see Pascal programs being written, this is what I usually see when I see a function. And take note, a function doesn't need to take in a parameter. If you just do that, the function will run without an issue, and we can just remove that. The parameter is just there so we can use it, but it's just like a procedure, it doesn't need a parameter. Now what we can do here is we can say if make. Not really sure why I called it make, but I didn't think it matters. So if make, then result becomes result plus 100, else result becomes result minus 100. And at the end we say res becomes result. Now we need to pass in something in here. So we say true, for example. Now it will become result plus 100. And we can just remove that extra end there. Say end here. Now if we run it, there we go. We get 150. And now if we make it false, we get negative 50. Now you might not quite understand the reasoning behind what I just showed you, but it's just to show you that all a function is just a procedure that can also return a value. And when it returns that value, you can print it out or store it in a variable or whatnot. But take note, you can still do whatever you want inside of here. You're not limited to something specific. And it also shows you to use a result variable instead of using res, or whatever the function name is, and only doing that at the very end. Because then you will never forget to assign to res, since it will always be assigned to result. But in short, TLDR, function is just a procedure that returns a value for you. If we make this a procedure, we cannot return a value. Let's say we have a box. So here, I'm just going to open up my drawing app. Alright, so here we have a box. A big box. Now it has a variable called x, and x contains the value 2. Now, this box can have another box inside of it. And let's say it has the variable y, and it has the value of 4. Now, when we print out y in this box, we'll get 4. That's pretty obvious. But when we print out x in this box, we will actually get 2. However, you should take note that if I were to reassign x here, x becomes 40. And we were to print out x then x will be 40. So if I reassign x, then its value will change. But if I don't reassign it, it will inherit the value from the box above it. But take note that if we were to print out x here, we'll get 2. If x was reassigned, we, depending on how it works, might get 4t. So x might return 40 if we reassign it. But take note, you cannot print out y. Y will give you an error. So ERR for error. Because y is scoped to this box here. But if this box were to have its own little box, and you were to print out y, you'll get 4. And it can go down like this forever and forever and forever. But the point is that you cannot access y in this outer scope box. But you can access X instead of its inner scope. So X is a yes, whilst Y is a no. So the deeper you go in, you can still access it, but you cannot access it on the outside. Let me give you an example. Let's say here we have a procedure. And this procedure, we can just call it birthday, has a variable called age. Now, age, we can say by default is 12, or let's go 120 because that's cooler. And if we say age plus, or age becomes age plus 1, and we right line age, we'll of course get 120. So let's call birthday here. And we can't print or right line birthday here because it's not a function, it doesn't return anything. We'll get 121. But we cannot access age from in here. We can't say right line age because this is in an upper scope. To give you an idea, so this is our main program, right? Take note, this is main. To give you an idea, let's say here we have our box. This is birthday. So B for birthday. It has age, which is 120. And in here is our main scope. Our main program here doesn't have an age. But you can't do this. You cannot share age from B to M. You cannot do that. These two are two different scopes. Similarly, you can't share any variables that might be inside of M here. You can't share it to B. Unless you call B, so you call it like a procedure, and you pass in that variable, in which case B, that might take in this variable, such as, let's say, birthday, and if that is true, so it's a boolean, so birthday boolean, if that's true, then age will become age plus 1. As an example, let's go here and say birth as birthday, and then this is a boolean. Now here we can just say if birth, then begin and end. There we go. So now if it's their birthday, age will become age plus 1. If we say true here, then it's 121. If we say false, it's 120. And this could of course be its own variable. So we can say for birth, or just so we don't get confused and make this something else, B for birth, and that's boolean. And if we pass in B here, and B is true, then we'll get 121. But we cannot right line B here. We can't do that because B is not in this scope. We cannot just send that value there. As you can see here, this not allowed, very big wrong. And even here, if we were to say birth becomes false, this birth becomes false will only exist inside of this procedure. When we go back here and we right line B, and of course we remove this B here and we just say age, and if we do that, you'll still see true because you cannot change the value of a value you pass in here. So this parameter will always have to stick to the same value. It will change inside of this procedure, so if we were to right line birth here, it would be false. So we run this, we'll get our false value here. But outside of this birthday function, the procedure, it will stay the same. However, you need to take note that our entire program is a scope. So this white page here, that is our entire program. If we were to put a variable a here, and a is equal to 4, then a is accessible to both b and m. So we can access a instead of both of them. Here we can change a to 2, so now a will be 2, and whenever we use a, we'll get 2. And here we can even print out a, and we'll get our value. Because this is our program scope, this is our file. That white part, that's our file. Which means we can do something like var age which is an integer. Now in your main program, you need to specify what age is. You need to give it its value. So here we can say age becomes 100. And we can actually remove that for now. And in here, if we don't specify any variable, let's keep this variable here. And let's write line age. Remove this birth here as well. And here we say our age variable, otherwise we're going to get an error, becomes 400. And let's actually not do that. Let's see what we get if we don't do that. We'll get nothing. Because age here, which is a local variable, because we defined it here, isn't given. So if we do this, we specify 400, and we actually need to call birthday, my bad. And let's actually just remove this again so we can see that result again. You'll see we get 0, because age is nothing. We haven't defined age yet, because it's declared locally. We declared a new one. As I said in the beginning, with this one, we can pass it in, and here we can change it. So take a look here. Here we change it, and in here it will give us that new value. Or in this case, if we were to declare x again inside of here, so not change it, but redeclare x, then x will not change here. It will never become 40, it will stay 2. Because it's of the outer scope, not of the inner scope. That is what's happening here. It might be confusing, but it's actually fairly simple. When we declare x here, and if we run this, we'll get 400. When we declare age here, we are saying we have a new local scope variable that is scoped to birthday. So it cannot be used outside of birthday, even though we have the same variable here. It cannot be used outside of birthday. This here can be used outside of birthday if we were to write line age. We'll get 100 for that one. So that will be the bottom one here, 100. But that age cannot be used inside of here. This is what's called a global scope variable, meaning this global scope variable can be used inside of any of the procedures and functions and anything else inside of this file. And a global scope variable can be overwritten by a local scope variable. So it can be basically be kicked out of the team. If we declare a variable with the same name as this variable here, then it will create a new one for that specific function. That's something you need to take note of. But if we were to do this, then take a look at this. Both of them will be 400, because when we call birthday, we are changing the global scope variable. Because here we first declare it, so we say what the initial value would be, just the initial value. Then here we're calling birthday, and it's changing the value of age and printing it out. And in here we're printing it out. If we were to swap these two, age would still be 100. But as soon as we move right line to underneath birthday, it changes. And that's a global scope variable. Here we can even say age becomes age plus 1. So when it's someone's birthday, their age will increase with 1. So here we can even print line age or write line age, and then do it again here. If we run it, we'll get 100, then 101. So this variable here can be used anywhere within this program, modified anywhere in this program, and give a value anywhere in this program. Now, this is very dangerous. You might have already noticed this. Age here can be changed anywhere without warning. Meaning if you call the wrong function at the wrong time, your global scope variable can be completely different from what you expected it to be. And in general, that's why it's actually recommended to never create global scope functions or variables. But when you do, basically, this age variable can now be used anywhere. Unlike variables that are created inside of these scopes. So if we go var x, which is an integer, and then we were to write line x, unlike this, and then of course just x becomes a bunch of 9s, which is actually too big, so got an overflow. Anyhow, this is local scope. So it's unlike this. So just take note, this var here, it counts as the local scope for this main program. That doesn't include procedure. This procedure here, so we cannot use it in here. Whilst this var here is global scope to everything around it. So it can be used anywhere. Now scoping of course becomes a lot more complex over time, but this is the general sense of how scoping works. If something is inside of a function declared as a variable, or even here, it is local scope to that specific function. In this case, it's local scope to this main procedure. But this procedure is the same here. If we were to declare a variable here like age, as I showed you, it will become local scope, locally scoped to this procedure. Same with a function. But if we declare it here, it can be used anywhere in the program, modified by any place in the program, unless it's a constant, of course. Now, a record is similar to, let's say, an object in C++ or an object in JavaScript. In a sense, you can define almost your own type that can hold properties inside of it. As an example, let's say type users. And let's say this is users that may be stored in the database. It is of type record, and we just say end. Then in here we can specify all of the values that should be stored inside of this record. Let's say the user's name, that's a string, and then we should maybe just say full name, just so we didn't mix with keywords. Let's say their age, which is an integer, and height, which is like a double, and a hobby, which let's say is like an array 1 to 10 of char. There we go. So here we have almost like an object that can store a full name, an age, and height, and hobby. Now let's create two users. So user 1 and user 2, which are of type users. And it might actually be better if you call this user because it defines one user specifically. Alright, so now we have our own custom type that contains its custom values. And it's simple enough to assign to this, for example, user1 dot full name, and that becomes Mike Jackson. And we can go user1 dot age, we can make that 19, user1 dot height, we can make that 1.8, let's say it's in meters, and we can say user1 dot hobby, and this right here is equivalent to a string in sense. However, you're limited to 10 characters. So this array of char here will actually allow you to store a string inside of it. It's just not allowed to be longer than 10 characters. So now you can say sleeping. So here we assigned values to the properties inside of this user. Now let's actually access these properties with write line. And we can just say name user1 dot full name, and let's also try to display age by saying age. Now if we were to run this, we get name Mike Jackson and age is 19. So we can access as well as assign using this dot notation. And that is actually most of this that you need to know. So you can assign using this dot notation, and you can access it using this dot notation. Now you might have noticed that typing out user1 dot, user1 dot, user1 dot, it became relatively cumbersome to do that. So what you could instead do is you could say with, and let's make this user2 now. So let's say we wanted to do this with user2, then we would have had to do this. But let's say we say with user2 do begin and end, and now we just plop this in here. Cool. But the difference is now we don't need to specify user2. We can just do this, because it will automatically infer that user2 should be added to the front of this. And of course you could do something like user1 dot full name is pickle man. And then if you wanted to display user1's data here, you will actually still need to use user1. So we can just go user1.fullname here, like that. So you can't just use full name here because then it will try and access users to full name. But with this with here, you can just specify these values and it will automatically infer, as long as there's no variables that has the same values here or the same names here, it will automatically infer that these belong to this user2. If we save and run this program, we can get name Mike Jackson, age 19, and user1 name is Pickleman. And that's the basics of a record. You ultimately define your own type that can store multiple values, and you can access as well as reassign them using this dot notation, or if you're using with, you can just use them as is. Now, a pointer is basically the memory address of something. So where that variable is stored in the RAM. Because each location in the RAM has a specific value assigned to it. Now, let's actually use it a little bit so I can kind of show you what I mean. So here we have a number, we'll just call it num, which is of type integer. But also let's have a num pointer, which is a pointer towards an integer. So take note of this caret symbol here. It's a pointer of an integer. Let's say we also have an address, and this is a pointer to a word data type variable. And let's just have a null pointer for later reference, which is a pointer to a string. So you'll get what I'm doing here. It's always a caret symbol and then the data type that is stored in that location in memory. Now let's say we have num, which is of type integer, so it's 5 times 10, which will give us 50. And then right line num, and just specify num, and we should receive num. There we go, num 50. Now we can assign num pointer the address that num resides in, so where in the RAM, the memory itself, this value sits, because this variable is stored in the RAM, and that RAM specific location has an address pointing towards it. So here we can just say num ptr becomes at num, meaning this num pointer becomes this pointer location here. So this at symbol will convert it from a normal number and instead get its location in memory. Now if you were to try and right line this, so num ptr, you'll get this. You cannot right line a pointer. You'll need to dereference it first by doing this, putting a caret symbol at the end. So you're dereferencing it, meaning if you run it, you get the value stored in that pointer. This pointer here itself is a memory location. If you want an address, you can do this. Num address becomes addr for address, let's say num pointer. So it will get the address of num pointer. And let's just also print out num address. And we will also need to dereference it. Now when we do that, and we add our semicolon where it's needed, and we run it again, we'll get address 59424. So that is the address in which this pointer resides in the memory. Now if you come from C++, you would have gotten this big hexadecimal value, but in Pascal, it is generally a lot simpler. Now, I don't want to go too deep into pointers. I feel this is territory you should most likely trade yourself. But to give you an idea, let's actually open up my drawing program that I love. So here is your RAM. So this is the RAM you have inside of your PC. To give you a simplified idea of what we're doing, let's say we create a variable x, and we say that is equal to 10. So we assign it to 10. Now, this x variable has a specific address. Let's say it is 225 842. So this is its specific address. Now this address is basically here. It points to this location in the RAM. So this is a very oversimplified view. So when we say, please print out X, then we're saying print out the value at this location. So then it will see, okay, you're at the location, but what's stored in here? And it will see 10 is stored in here. Then it will return that 10, and it will print out 10. So we're telling it, or here it's telling it that X is this location in memory. Behind the scenes, this is what's happening. It's basically actually just storing an address inside of this X, but we don't have to worry about that. We just worry about the value. But behind the scenes, there's actually an address that points to where this value is stored inside of the RAM, and literally where this value is stored in it. On other news, you can also have a nil pointer, and a nil pointer is just a pointer that has no value, so it has no location it's pointing to. That means that it's empty, so it's not pointing to any specific location in memory, meaning there's no value it's trying to reference. So we say if nil pointer is not equal to nil, then we know, right line, something is inside the pointer. So if this value is not nil, then we know there's something inside of the pointer. In this case, there's nothing inside it, so it doesn't print out anything. But let's say we choose num pointer here and put that there instead of nil pointer. Then we'll get something is inside the pointer. And that's the basics on pointers in Pascal. Thank you all for watching. I hope you all enjoyed. And I will see you all again in the next tutorial.